Okay, welcome back. Here we go. Lesson 19, Complex Fractions and Review of Order of Operations, otherwise known as PEMDAS. Please excuse my dear Aunt Sally. So we've dealt with order of operations in the past. It's just that now we're going to be operating on fractions. So before we do that, let's take a look at complex fractions, though. So a fraction whose numerator or denominator or both is contain fractions is called a complex fraction. So notice here we have a fraction on top of a fraction. Here we have the sum of two fractions on top of the difference of two fractions. Here we have like a whole number plus a fraction over a fraction. So all of these would be sort of the formats of complex fractions. Question is, how do you simplify them? All right, method one, simplifying a complex fraction. This method makes use of the fact that a fraction bar really means division, right? So, obviously I have the answer pasted in, but I want to do this in real time. So a lot of people, when they look at 2/3 over 8/9, they say, gee, doesn't that really mean 2/3 divided by 8/9? Which in turn means 2/3 multiplied by the reciprocal, right? And then when you arrive there, you can travel straight across, or you can do cross cancellation. If you're a person that gets mixed up by cross canceling, then don't do it. Just travel straight across and say 18 over 24. Question is, does 18 over 24 reduce to 3/4? You can say, well, I'm going to divide the top by 6, the bottom by 6, that common factor of 6, and yep, 3/4. So method one means we can look at, basically, let me make it bigger here, we can look at this fraction bar right here as in essence a division sign, right? And rewrite the problem as division. That's one method. Let's look at the next slide. All right, now let's actually continue with method one on this more complicated version, and then I want to start to talk about another way to deal with these complex fractions. But for now, okay, so let's take, let's view this fraction bar right here as a division symbol. So let's basically add these, then let's, subtract these. Let's deal with it in bits. And then turn it into a division problem. Well, let's see. A half plus a 6. Well, we need the common denominator, which is 6. So we can do this in another color. Multiply by 3, multiply by 3. Aha, so then we'd have 3/6 plus 1/6, which is clearly, and let me scoot, this is the final answer to the problem. I'm just going to scoot that off to the side. So that's 4/6. So we have 4/6 for the numerator. Now let's deal with the denominators. All right, well, 3/4 minus 2/3, the LCD is clearly 12, right? So 12, 12. How does 4 become 12? Multiplied by 3, so we transform those fractions, having the common denominator. How does 3 become 12? Multiplied by 4. So now we see we're going to have 1/12 in the denominator. So after all that sweat equity, let's take that. So now we've got 4/6 divided by 1/12, which really means 4/6 multiplied by reciprocal. And that's going to take us, if you just travel straight across, that takes you to 48 over 6, which is 8. So, and that was the final answer. So again, one way of dealing with this is, to find the LCD for the top two fractions, add them, get a result. Find the LCD for these bottom two fractions, subtract them, get a result, and then turn it into a division problem. So this is actually phase 1, this is phase 2. Okay? Now me personally, that's way too much work. Maybe there's an easier way, and I'd really like to sell you on that. So, simplify a complex fraction. Find the LCD of all the fractions in the entire problem, in the numerator and the, so look at 2, 6, 4, and 3. The LCD, I'm going to say it like this, for every denominator in the entire problem is clearly 12. So take that LCD of 12 and just follow my recipe here. Multiply 12 through to all the numerators of the problem. And this has the effect of leaving sums and differences of terms in the numerator and the denominator, and thus a simple fraction. Let's just try this. So note to self, multiply LCD to numerators only. And poof, it's all going to clean up, I promise. All right, let's see how that works. Got to do some mental math. Or you can write something out, but 12 times 1 is 12. But 12 on top, and keep the 2, so 12 on top of 2 cleans to be 6. 12 times 1 is 12, but 12 on top of 6 cleans up to be 2, right? So after all that, you're left with 6 plus 2 on top. Now try again. 12, you're going to send it through to these numerators. 12 times 3 is 36, but 36 on top of 4 is 9, meaning divided by 4. And 12 times 2 is 24, but 24 over 3, that's going to clean to be 8. Well, gee, check that out. 6 plus 2 makes 8. 9 minus 8 makes 1. Hey, 8 over 1 is 8. Well, wow, that was really easy to do. And, just think about it like this. I'm going to rewrite the problem. If you take that common denominator through, I just draw giant brackets around it, take the LCD, I'm going to do this, and again, send it through to the numerators only via multiplication. And if you do it in your head, what I'm saying is practice it mentally. You can arrive at this step very easily. 12 times 1, 12 divided by 2 makes 6. 12 times 1, 12 divided by 6 makes 2. 12 times 3, 36 divided by 4 makes 9. 12 times 2, 24 divided by 3 makes 8. See? So just practice, mentally getting to this stage. That's a fun little game. All right. So that's method 2. And then last but not least, we want to, now that we're so good with fractions, we can perform order of operations. Please excuse my dear Aunt Sally. Parentheses, exponents, multiply, divide, add, subtract with fractions. So let's go for it. Here's the first one. So we take care of parentheses first. So I would just kind of rewrite 2/3 plus 1/2. The LCD is 6. So that's 4/6 plus 3/6. So we operate inside the parentheses and just force yourself to record every little thing. You can take care of your exponent here. You can almost do that off on the side. Negative 2/3 cubed means negative 2/3 times negative 2/3 times negative 2/3. So that's going to bring you to negative 8 over 27. So I'm just going to kind of do that off on the side. So negative 8 over 27. Keep cleaning inside these parentheses, so that's going to bring you to 7 over 6. And then keep, writing the whole problem out. So constantly recording your thoughts. It's sort of the name of the game in algebra. So parentheses, exponents, multiply, divide, add, subtract, right? So we took care of parentheses, took care of exponents, multiplies, anything connected with multiplication. Yeah, these two. So we multiply, that's going to be 14 over 6. Remember, 2 is really over invisible 1. So 2 times 7 makes 14. 1 times 6 makes 6. So take care of that. And then I'm just going to force myself to write out every little thing. Then take care of division. Well, right here's division. And division really means multiply by the reciprocal, right? So we have negative 8 27ths times 2 over 1 plus 14 over 6. When you arrive there, you have to, multiplication dominates addition, so And by the way, always signs, negative times a positive is a negative. So negative 16 over 27 plus 14 over 6. When you arrive here, you have to get the common denominator for 27 and 6. If nothing pops into your head right away, just take 27 times 6. You can always reduce it at the end. So let's go with the 162. And you can almost do this in another color. Do rule, 27 needs 6, do to the bottom, do to the top. 6 needs a 27, do to the bottom, do to the top. And yeah, we're wheeling and dealing in large numbers, but I'm sure you can handle it. So 16 times 6 is 96, but it's negative. See, negative times a positive. So negative 96 plus, and 14 times 27 is 378. And voila, we're almost cooked. So then negative 96 plus 378 is something? 282. So you arrive at 282 over 162, which is great, but the question is, does it reduce? And you know it's even, so you can at least start by dividing by 2. Should reduce into 47 over 27, and I'll let you play with that on your own for time's sake. Hope that helps. I can tell you if you're trying to reduce this by hand, you could start off by dividing by 2. But remember our divisibility rules. 8 plus 2 plus another 2 makes 12. So the top's divisible by 3. 6 plus 2 plus 1 makes 9. So the bottom's divisible by 3 as well. So you can start by dividing both of these by 3 as well, at least to get you onto the path of reduction, of reducing that fraction to lowest terms. So this would be your final answer. Okay, hope that helps. And you can always rewind, pause and rewind, and try to go back and hash that out again on your own. And I think this is our last one for today. Yep, last slide for the guided notes. Okay, let's try one more time. Inside the innermost parentheses, always thinking about PEMDAS telling us to do the parentheses first. Okay, so half minus 3/4, LCD is 4. Okay, so 2/4 minus 3/4, whole thing squared. And then the rest of the stuff I'm just going to force myself to record. Well, 2/4 minus 3/4 is negative 1/4. But then he's going to be squared and then multiplied by 2 and then the rest. Okay? Negative 1/4 squared, I'd go off on the side. I always do like a little side zoom. Means negative 1/4. Anything squared means that thing times itself. So negative times a negative is a positive. So that's going to lead us to 1/16. Okay, so 1/16. Then 2's hanging out, being multiplied. And then here's the kicker. This right here is where a lot of people accidentally goof. Okay, right here. Careful. PEMDAS says you would think you'd multiply before you divide. Remember, you move left to right over those brother-sister operations. Must move left to right over multiplication and division. So I'm actually going to move left to right here. I'm not going to perform multiplication first. Tricky. Big note to self. Tricky. Okay, just move left to right. So another way of saying that is, hey, change your division symbol into multiply by the reciprocal. So negative 1/3 multiplied by the reciprocal of 2, which is a half, and then dot 1/16. Once you arrive here, yeah, just move left to right. So obviously answer is going to come out negative. Negative 1 times a bunch of 1s is negative 1. 3 times 2 is 6, and 6 times 16 is 96. And voila, you got it. All right, that takes care of your guided notes. Good luck out there.